This is going to be the what JS developers need to know about the JWTs. It's presented by the fabulous Akira brand. Akira is a software developer and educator. The roles have included employee, contractor, hackathon organizer, and nonprofit leader. They currently work in developer advocacy at Fusion Auth, a Denver company building software to handle authentication, authorization, and user management for any app. As a recent passion project, Akira and some peers created a weekly hackathon exclusively focused on helping new developers learn the basics of front-end web development called Learn a Bit. If you find them, or you can find them at www.akirabrand.com. And with that, let's give it up for Akira.
Hi, everyone. Thank you very much for the warm welcome. So I'm going to talk about JWTs, otherwise known as JWTs, JSON Web Tokens, and what JavaScript developers need to know about them. If you were just in the previous talk with Tyler from Auth0, he also went over this really briefly. So this is a deeper dive. Again, this is not meant to be exhaustive. We only have half an hour. There's no way I could teach you everything about JWTs in half an hour. There's like books and books written about them, but this is just a place to get started. Again, demystify some of the buzzwords about it, and just kind of see how it all fits into your work as JavaScript devs. Really quick, a little bit about my company. I work for a company called Fusion Auth. I'm a developer relations engineer. We are a customer identity and access management shop. We do everything that has to do with authorization and authentication. We support OAuth grants, SAML, passwordless. We have 3 tiers. We have a enterprise tier, developer tier, and then a free community tier that supports as many users as you want. It's really great. It has a robust community around it. I myself am often popping into the forums and answering questions, and that comes free with the developer tier. We're trying to figure out how to make money. So with that in mind, we also produce a whole heck of a lot of JWTs. A little bit about me. Again, my name's Akira. I've been developing software since 2018 professionally. Before that, I messed around quite a lot in computers, also in electrical engineering. My previous career was actually a classical musician, so I sing opera. I also was a conductor and a music director at many more traditional churches that focus on classical music. One last thing about me is that I brought a ton of t-shirts with me, so if you want a Fusion Auth t-shirt with like an inside joke about reading out your passwords via the command line, come find me. And people can be like, what does your shirt mean? And you'll be like, well, let me tell you. All right, so what are we going to do today? So first off, I want to briefly go over what is Auth. Again, if you came to the previous talk, you might have a little bit of context, but if you're new, we need to talk about the overall context inside of which JWTs live. We're going to talk about how JWTs fit into that process, and then we'll have a little bit of time for questions at the end. So what is Auth? Okay, who here has traveled to a foreign country? All right, when you travel to a foreign country, what do you need to have? A passport, right? So a passport kind of works as a way to authenticate who you are to this foreign country. It is a verified, certified document that the other country's customs agent trusts, and it says, this is who I say I am. So that would be the authentication part of a web app. Now, if you are a journalist, or maybe you're a diplomat or an elected official, inside of your passport, you might have a special stamp or an extra page that says this person is allowed to access war zones or diplomatic buildings or certain areas that a regular citizen cannot. That would be the authorization part of an app. So that is what you can access based on who you are. When a user authenticates to a server, they are proving who they are to that server. And when a server authorizes a user, they are granting them access to particular resources based on who they are. All right, so our app. A quick side note, we had a big snafu with my computer today, so many thanks to Hayden for letting me use his. I was almost about to pull people from the audience to demonstrate the app. So someone was going to be like the to-do API, someone was going to be, but we don't have to do that. So, but anyway, so that being said, we all kind of lucked out today. But this is the app that we're going to step through to use as an example. And then talk about why JWTs may be a good fit for a service-oriented architecture and why they may not be. So this is probably the most intensive to-do app you may ever see in your life. We have a to-do API and a user API, so two separate APIs that are going to be calling information from the data store. The most important thing I want you to really take away from this talk, if anything, is that on the left side, we have, of course, the web. We have a mobile device. That is the open, untrusted web. And we want to stay away from storing or communicating sensitive information over that untrusted web. So that's where things like JWTs and opaque tokens come in, is it helps us keep a lot of this sensitive data on the right side, which is the trusted server side of our app. The data store of the user API may be users, user roles, overall roles, and then the to-do API data store would just be a to-do list. Okay, so why would we use maybe opaque tokens and JWTs? We're just going to kind of compare and contrast those, right? Because sometimes the best way to know what something is to understand what it's not. So we're going to go over first opaque tokens, and then we're going to go over JWTs. And both have pros, both have cons. Both are really confusing. So if you feel like this guy on the bottom, like, I understand. I feel like him often as well. All right, so first off, let's talk about opaque tokens. And how the flow works, and this will also give you an overall view of how the flow of using JWTs work as well. So first thing, user log in on the untrusted open web, and they're going to pass their username and password, usually it's hashed, to the user API, right? The user API is going to look for that user ID and password in their user data store. Now, in a sort of naive implementation, they would find that, and they'd say, yep, you exist, here's the user ID, and here's some credentials, and pass it back to the user on the client side. But we're not going to do that. Instead of passing back things that can be easily seen and exploited, they're going to pass an opaque token. That token is a way to say, hey, okay, I'm issuing you this trusted resource, kind of like a passport, right? That says you are who you say you are, that you can then take and give to any other API in the web. So the user presents then that token that is passed to them by the user API to, in this case, the to-do API is a way of saying, hi, I am Akira brand, and you can trust that I am because I have this opaque token that was issued to me by a trusted server, in this case, the user API. So the to-do API then says, okay, let me check with the user API that they did, in fact, issue that to you because I don't know you, and I just need to let me double check. So what it'll then do is it'll go to the user API and verify that the user API did in fact issue that token. Once they see that that is the case, they will get the user data directly from the user API based on who that user is and pass it back to the client. So that's an okay way to do things, right? There's nothing inherently wrong with that. But there are some sort of pitfalls, right? There's some foot guns to that. First off, there has to be a user token mapping. The process itself can be very chatty. As you can also see here, everything is coupled to the user API. So if this user API falls down, that's it, your app's done, right? Or maybe you have many, many different APIs that need to go back to this user API over and over and over again, and that's going to take up a lot of time. So it's a little chatty, it's coupled, and we don't want to have to go back to the user API every single time we want to authenticate a user. So this is JWTs to the rescue. If you're a 90s kid, you might remember Buzz Lightyear to the rescue, so just replace that with JWTs. All right, so I'm not going to be up here and being like, this is the way, right? Like, JWTs are not the only way to do things. This is just another way to approach things. So this is how a JWT flow works. So a user tries to log in, pass the username and password. Instead of issuing an opaque token, what is issued by the user API is a JWT, or a JSON Web token. Not only is that JWT created, it is also signed. And in the world of JWTs, nothing else matters, right? Like, that signature is so important. We're going to get to that in a little bit as to why. So the JWT is issued and signed and passed back to the client. The client will then present that token anywhere they want. In this case, it's going to be the to-do API. The To-Do API has been written in such a way, and this is also really important, to verify all of what are called claims on this JWT. So it will examine the JWT and say, okay, who is this from? Am I the intended recipient? And how long is this JWT valid for? Has this JWT expired? Again, we're going to go over that in a little tiny bit. One other thing that is really important to mention here about signatures, if the token is tampered with, because you can examine JWTs. If you go to your network tab in DevTools, you can just go to what are called bearer tokens. Those are JWTs, and just look at them. You can decode them, and as such, you can tamper with them. So if you're not being intentional with how you're examining these claims from JWTs, someone can take your JWT, redirect it to their like hacker evil server, right? And then it's game over. So that's also where the signature really matters, because if a JWT is signed and someone has messed with the payload, the signature is only going to essentially give a check mark or a pass to that particular payload. So if the payload has been tampered with, the signature will say, sorry, like I didn't sign this, I signed some other document, so then the JWT itself will become invalid. Okay. Let's talk about the anatomy of a JWT. All right, so again, last talk we went over this a tiny bit, but let's just do another deep dive. First section is, what do you think? Header, body, or signature? Who thinks it's header? Yeah, hey, it's head on top, good job. Okay, second section is body. Third section is signature. So the header has a little bit of information in it. It will have the type of algorithm that was used to sign the JWT, in this case, HS256, and then, of course, the type of data that this is, which is a JSON Web token. This next section, which we'll get into a little bit more, has the actual payload of data. So this is the claims, and then what's inside the claims. So you can see these are key value pairs. Why don't we call it keys? I don't know. We call them claims. There are standardized and non-standardized claims. In this case, the first four, ISS, EXP, AUD, and SUB, which I totally expect you all to remember because there's going to be a quiz, are standardized, and the last two are not. Also, something that's kind of nice about JWTs is that you can pass anything in a JWT that you can pass in a JSON object. So those last two sections are just to show that you can do arbitrary JSON data. You can do arrays, objects, strings, whatever you want. If you actually, and I'll post these slides on my Twitter when we're done, you can take this JWT that I put and decode it, and this will be what comes out, which is kind of cool. And then, of course, the last section is the signature. Okay, so again, just want to go over this one more time. The signature is important because if someone messes with the payload of data, the signature only verifies that payload. So if someone has messed with it in transit, because they'll try, then the JWT will be invalid. For what it's worth, there are cases where people use JWTs and they don't sign them. That is usually only when they're on, again, very much that right server-side trusted network exclusively. So maybe a home network, an office network, where every single machine on that network is trusted. However, if you're on that level of networking, you're probably not using JWTs in the first place. So I just want to make sure that you do know, yeah, you can do that, but you, as JavaScript developers, you probably won't. Okay, let's go over the claims. So the first one, issuer. That is who issued it. Who made this JWT? Who signed it? In this case, FusionAuth.io. When you are examining these claims on APIs that you're developing, you want to make sure, is the issuer of this JWT someone I trust? And if it's not, don't go any further. It's not a valid JWT. Second off is the expiration. JWTs are what are called bearer tokens, which means that anybody can grab them and use them. It doesn't matter. It's not tied to the client. It's tied to the issuer. So any person can grab it and try to give it to somebody. It's kind of like a car key. Like, I can give the car key to you or to you or to you, and then you can go drive my sweet Honda, right? It doesn't matter who you are. What matters is that you have the car key. So it's important that we put an expiration date on it. Think of this almost like if there was some kind of way to do car keys for valets, and they were only good for maybe 10 minutes or something, and then the car key would no longer be valid. I think that actually that there's like currently, I think in Tesla models they do something similar. But that's important. So you need to see how long has this JWT been around. If someone is trying to reuse a JWT that's been expired, no go. Sorry, it's too old. Don't want to use it. The audience is who is it for? Is this JWT for me? Always be validating your claims. Am I the intended audience of this JWT? If I'm not interested. Subject is who is the JWT about? So that would be like, oh, this JWT's about Akira. This JWT is about Dan. This JWT's about Ruth, whoever it is, right? And then again, those last two are just arbitrary JSON data. Now, okay, one thing I do want to mention quickly, don't put sensitive data in a JWT. Don't put someone's birthday or their social because anyone can see it. One thing I think would be cool, if you're interested, is go to any website and see if you can find a JWT. Again, it's in your network tab. It'll be in the header section of any of your HTTP requests, and it'll be under the key of bearer. That's a JWT, and you can put it in a JWT debugger and look at the payload, which is pretty cool. All right, JWT benefits. Signature adds an extra layer of security. They're decoupled. As you notice, I don't have to go back to the user API every single time I want to verify that this user is who they say they are. So if the user API falls down, well, bummer, I still got my JWTs, right? You can use roles, you can use other metadata, put anything you want in a JSON object into a JWT, and there is some advantage to it being a bearer token, again, mainly because it is decoupled. All right, couple gotchas. This is important as well. There's a lot of ways to configure a JWT, and I feel like this is where JWTs get the most hate, right? It's like, look, there's so much room for error. Like, why would I use this in the first place? This is supposed to be more secure, and I feel like the way that it's being used is actually making things inherently less secure. Use a library. Use a library. Don't do all the work yourself. There's lots of good open source libraries out there for configuring your JWTs. Another thing, again, that I keep harping on is verify those claims. If you write code to verify the claims, beautiful. JWTs are super secure. They're awesome. You can be really great using them. But if you have to, if you only verify like one claim, like who's the issuer, or you verify 0 claims, then you're going to get yourself into trouble. And then again, the nice thing that is nice about JWTs, you can have any kind of data you want in them that you can put in a JSON object, but if you're being maybe sloppy or you're not aware and you're putting in things like social security numbers, date of birth, well, anyone can just grab that. All right, let's talk about token storage. You have a JWT. Great, that's cool. That's great, Akira. Like, what the hell do I do with the dang thing? So, when we're going to store JWTs, we prefer to do on the server side. We call this the BFF pattern, which I get a huge kick out of. Like, the front end and the back end are best friends. All right. So back end, front end pattern. If you need to store them on your browser, please do it in an HTTP-only cookie. Please do not do it in session storage. They are too easy to tamper with and intercept. If you do it in session storage as well, you're gonna get cross-site scripting. So do it in an HTTP-only cookie. If they're on mobile, I personally don't know a ton about mobile development, but push it down, secure storage. Okay. Let me make sure I have enough time to talk about public-private key pairs. Yes, I do have enough time to talk about public-private key pairs. So let's talk about public and private key pairs. Okay, this is another layer, yet another layer to JWT security. So again, we're all engineers in here, right? So there's not a one-size-fits-all answer. There's not a silver bullet. A lot of this is really a it depends kind of situation. Maybe you have an app that has a lot of security that you need to keep in mind. Maybe it's a banking app. Or it's an app that's HIPAA compliant. It has healthcare data. Maybe it's other kind of sensitive data that you really need to be careful that whoever is getting access to it is who they say they are, and you need to add that extra layer. That is where public-private key pairs come into play. So what would happen? The user API would issue a JWT, and they would sign it with a private key. Woohoo! All right, so the private key has a matching public key. Now, the issuer of that JWT, such as Fusion Auth or Auth0 or another Auth server, maybe you write your own, please don't, but if you do, that Auth server signs the JWT and publishes the public key. So then, when that JWT is issued to the user and the user passes it to the to-do API, the to-do API will see, oh, this has been signed with a private key. Let me go find the public key that has been published on the web via the authorization server has published it. then they can use this public key not to decrypt the private key, but to verify that this was signed with the private key. So this is just another cool way to add, again, an extra layer of security. The authorization server that signs it and issues the JWT, again, will publish the public key. And just again, to reiterate, the public key does not decrypt the private key. The public key just verifies that it was signed using this particular private key. All right. There's really interesting also cryptography that goes into that. Some really fascinating math that I can't tell you right now, but it's interesting to look at. So TAN-STAFL, if you know what TAN-STAFL means, come find me. I'll give you a free shirt. But this is not perfect. It's more complicated, for sure. It's far slower. So again, if it's trade-offs, right? If you need higher levels of security, you want to use a JWT, try it out, but it's going to be slower. But again, it is more secure. A couple of tools that I will have on the slides, and again, I'll publish them on my Twitter later if you want to see. And that's it. We were going to do a little demo, but again, the snafu with my computer, that's the end of that. So I just want to say thank you. And let's open it up for questions. If anyone has any questions on JWTs or Fusion Auth or how this kind of all fits into anything, now is your chance.
Why are JWTs encrypted if you can ultimately just go to jwt.io and encrypt it?
That's a really, really good question. So actually not all JWTs are encrypted. There are encrypted JWTs, but they're not widely used. So does that answer your question? Kind of, sort of? Yeah, like I guess maybe the main question that you're asking is like why use a JWT in like the first place, if you can just examine the payload. Yeah.
Less data over the wire versus sending my name is supercalifragilisticexpialidocious, my basic SQL info that it's going to be a shorter footprint to send over the wire.
Exactly so. Thank you. I will send you a check in the mail. All right, what other questions do you guys have? Let's maybe take like 2, 3 more. I'm not sure how much time I have left.
So in your example, you were passing the JWT token to the to-dos API. Is there a formal term for an API that receives a bearer token? Is that like a bearer server or something like that?
That's a good question. I honestly don't know. But yeah, does anyone else know if there's like an actual official term for that? Like a bearer server if you use a bearer token? I don't think so. I do think that bearer tokens can be, yeah, I don't know. I don't want to like just kind of like riff because I'm not sure. So I'm going to leave it, I don't know, and I don't know. Mm-hmm.
In OAuth, that's called the resource server, and it can accept different flavors of tokens, but one of those is bearer.
Yeah, that's fair. Okay, let's do maybe one more question. Yeah, you're the one.
I'm wondering if you have experience or if you found a good way of sharing common secrets, like if you use Vault or some other way, if you're passing JWTs between like microservices or something like that.
I see.
How do you keep track of like rotating secrets and storing multiple secrets that maybe 3 or 4 different services all need to sign and validate JWTs?
Yeah, so that's a really good question. I personally do not have experience in doing that. As far as that goes, that's a really good question. Gosh, I feel like you guys are asking me good questions, and I keep saying I don't know. So yeah. All right, cool. All right, so yeah, yeah, go ahead.
I might be able to say something.
Yeah, sure.
As far as that's concerned, there are a few different services out there. Like, for instance, there's the Azure Vaults, but then there's also like some safe storage, encrypted storage places in most any of the cloud services that you can find out there. Yeah, AWS and what have you.
Yeah.
So you can do that. I've also used in a previous company that I've worked for a thing called EnvKey, and it's sort of helps to sync everything across the way, and it can help actually inject some of those tokens at deploy time, and so that it's actually available inside of the environment itself, which means that it's only as safe as your environment is kept on your server. So that's an option as well.
All right, cool. Well, thanks again, everybody. If you want a shirt, come find me. And yeah, thanks again for coming.